Yeah, I think we're gonna just start in about another 10 seconds. So it's, yeah, just give me 10 seconds. I'm kind of setting up something. All right. Can you kill my microphone for a minute, please? Okay. All right. So good evening, New York. Good evening to everybody, and good day to everybody wherever in the world you are in terms of listening to this presentation. So this presentation is Windows Azure Basic. It's 1100 presentation, and where I'm going to be covering on Windows Azure as what does it bring on the table at a level 100 level. There are going to be some more sessions around the Windows Azure specifically to the development part of it, and there are quite a few sessions which I'm going to be doing in a couple of days. You're going to, so you probably want to watch my site where I kind of load all of these presentations. So great. So I think we get started. Now, my name is Ajay Solanki. I am an architect, practicing architect for about roughly about 4 to 5 years. And last 2 years I've been, I would say last 18 months I've been digging around a lot on cloud. And seriously, last 6 months I've been playing around with Windows Azure and kind of looking at very, very closely. So today, let's get on to the agenda. The goals of this presentation is what I want you to, what I want you guys to really take back from this presentation is a, if you were to kind of articulate what Windows Azure platform is, you should be in a position to go back and tell people maybe a 5 or 6 minute pitch in terms of what Windows Azure platform is and what is really built about, and what is it that interests you in Windows Azure platform. And there are plenty of areas where you guys are going to find areas of interest. Now, if time persists, we probably get into the second part of the presentation, that's understanding typical scenarios. Now, if I look at Windows Azure platform, now there are places where I would use Windows Azure platform pretty straightforward because it's an easy fit. But in certain scenarios where I really can't get Windows Azure platform to do a apple-to-apple comparison with an on-premise application, I probably look at things differently. Okay. Uh, Sorry for that ring. Now, moving on to the next slide, we coming down to, okay, how do I really go about defining cloud computing? Now, broadly, cloud is divided. I mean, there are various connotations, there were definitions in terms of how to define cloud, but the way I see is a little different. So, I see it. I'm trying to simplify things as far as possible. So, where I'm looking at, you have cloud applications. So cloud applications is typically something like an Exchange Online, a BPOS, a Salesforce. So the application's already there, and you, your mom, as end users get onto is like typically from a browser or something and go ahead and use it, and we only pay for what we use. So that's something which I actually call cloud applications, and quite often in the industry this is referred to as software as a service. Okay, and however, that's not our topic today. We are going to be talking about cloud platforms. Now, if you were a developer today and you write some code and you basically want to take that code to the cloud, what is that you're going to be doing? What do you expect? So you need to have some background knowledge in terms of platform. But if I look at an on-premise application, uh, you probably put the application on an IS server with some kind earlier and you put your business component or maybe on an application server and so on so on. So similarly, as a developer, I would go ahead and put the application on the cloud platform and say, hey, cloud platform, here's my app, go run it. I really wouldn't care about the infrastructure. So it's a platform for developers to kind of go ahead and say, okay, here's my app, go run it, and I'm not really bothered about load balancing the app, whether the memory is right or wrong, etc. Blah blah blah, and I would just go ahead and give it. So that's our focus topic today. So if I look at Windows Azure platform, at a very base level, you look at Windows Azure, the one which is marked at the bottom. So we're looking at tired base architecture, and Windows Azure is your base, where it's got a lot of features. We're going to dig into the Windows Azure and the features around that. So for right now, just hold your thoughts, and we'll actually get down to there. Then we have Windows Azure App Fabric, which is more of the infrastructure services, and we have SQL Azure. So SQL Azure is something like an on-premise. You have on-premise SQL Server database. So it's like, think of it as like SQL Server in the sky, in the cloud. And then we have the Windows Azure Marketplace. So the Windows Azure Marketplace is typically the place where I actually want to go buy apps, and if I build apps and I want to go and sell them. So it's a set of data. It's a data set and application. That's the way we'll kind of look at it. It's more of what we build. We want to go ahead and sell, make revenue out of it, and over about this, you actually see the application data. So categorically speaking, if you look at this diagram very very closely, it's a tiered architecture, and there is a base platform with some services, there's database, and there's infrastructure services, and on top of that you actually have, so we don't really move away from what we've been doing, what we've been practicing on premise for such a long period of time. So let's get on to Windows Azure as a base foundation, and this is what we get. Your applications and your data are going to be running on a specific computer, and we are going to be needing compute. And if we need compute, so that's actually CPU compute. I'm expecting, it's going to be running in some server, some virtual instance, and I also need storage because my application would need to store the data somewhere. So the storage what is provided in Windows Azure is different from what is there in SQL Azure. So typically what we have is queues. We got tables, and we have blobs. So there's basically three categories of storages which actually Windows Azure kind of brings in. But I guess the most important point of this presentation which I want to make is, you see the set of 8 boxes right down below, which is something new for the moment. So if you look at a data center, we have a big host of machines, maybe 8, 10, 220, who knows. And now let's say each of this machine is having roughly about 4 cores. So we're talking about 800 cores, assuming there are 200 machines. So 800 physical cores, and I want to kind of use all of the 800 physical cores differently. When I say differently, I really don't want to be bothered about going ahead and installing my application on a specific core, and I actually just want to give it to somebody. Say, hey, here's my application, go run it. And the application, the fabric controller. Here in this case, this is a fabric controller which basically controls the part of taking the application and running it, monitoring it. I'm sorry. We're going to take questions later on. As a standard practice, I try not to take questions during the presentation. I kind of do it towards the end. So hold that question. We got to get there. So if you look at a fabric controller, it's pretty much managing its infrastructure. It's a service which basically manages a set of servers, and it gives us the flexibility to run all our application using the compute and storage of all the box consolidatedly. I could run an application virtual instance on a box, and then eventually then kind of kill that and move it to another box because I'm doing a service pack upgrade on that box. So all of that part has actually been done by the fabric controller. So fabric control essentially is the heart of the Windows Azure platform. And essentially, if I look at Windows Azure, like what you have Windows 2008 to the server, Windows Azure is the operating system for the cloud. You got to understand that. So here we are not talking about a single machine. We're talking about a set of machines. You have 800 cores, and you just want to go ahead and use it so flexibly that I can run an application on a specific virtual instance, and then load balance it with another instance, and then kind of run it over and kill it and move it onto another instance. So basically, there's a lot of things which actually go in. So when we get into the fabric controller part, we actually going to be going deeper into that. So we have the infrastructure services, we got the compute, we got the storage. What do we need next? Now my applications which are actually running on the cloud obviously would have at some point of time the need to connect with applications which are running on premise, which are necessarily behind the firewall. I'm sorry. So how do we really go about doing that? So connect is that piece which kind of allows uh, application on-premise or cloud or elsewhere to connect with other application on-premise, on cloud elsewhere. We have a separate slide on the compute on the connect part, and we will get to a minute as to how do you really go about doing that. The last part on the extreme right hand side top we see is the content delivery network, the CDN. So there's a bit of confusing around the terminology. So CDN could be content distribution network, content delivery network. So for now, I'm going to live with content distribution network. The CDN essentially, now look at it this way. I'm going to be storing data on Windows Azure in terms of blobs, okay, binary large objects. And now what would I typically store in those blobs? Maybe video, audio, and I'm basically now I want to stream this file closers, quicker and faster. So you got it in the data center somewhere in Asia, and you basically want to. There's a user out of the US who's accessing that data, and how would one do it? So CDN brings that feature of allowing that data to be closer to the user. So by that, what I need to say is that you have another edge server. You kind of copy the data from the Asia server to the edge servers back in New York or in the US or Europe, and that's how you bring the data. So you cache it up. So we get down to the CDN part in a minute. So let's get down to the Windows Azure Compute. Now, if I typically look at applications, which the application architecture today, what I see really is in a web application, I have the web tier, the presentation tier. I have the database and the business tier. So we got three tiers. We got business tier, database, and you can actually go ahead and complicate things and make it put a service tier as that. So it can be entire based application architecture. Now, if I were to port that onto the cloud, so I would expect the cloud. If I'm a developer, I would expect the cloud to kind of have some kind of continuity in terms of what I'm doing on premise. And so, what would I expect? I would expect that my web application, the presentation part, would continue to run as the web. My business applications, which are a part of business components, which don't necessarily interact with with the outside world through the HTTP protocol, but they may kind of interact with the inside world, maybe through another application, and so on and so on. So basically, that's what I call a work role. And if I look at the web role, and the worker role, and the VM role, they are virtual instances. So, mind you, take this with a pinch of salt. When I say a web role virtual instance, so there is actually a Windows Server 2008 virtual machine which is running with IIS on top of it, and you have kind of posted it, you kind of installed your app. So because Azure takes your web presentation layer, put your HPX and the DLL onto that IIS box, and expose the endpoint to the world, and that's how your application runs. And if there were a set of components which let's say a Windows service or a WCF service which kind of talks to the web role, I would go and give it to Azure, and Azure would kind of say, okay, hey, this is a worker role, so let me just go and install this onto the worker role, onto one of the virtual machine instance of worker role. So you need to understand out here, every web application that you give, and you kind of deploy it, Windows Azure makes sure that it runs on a single VM instance of your own. So if I had a web application and you had a web application, we would never end up running on the same virtual instance. So we have isolated boundaries of virtual instance. We have our individual virtual machine, but we don't have access to these virtual machines. That's a different story. That's what Microsoft tells us, that every web role and worker role is going to have its own independent virtual instances, and they are load balanced. Now, think of it this way. Now you have your virtual instance which are running on over the Fabric controller, and on some other box which is on some physical machine. And now if you kind of go ahead and just deploy one web role, and the Fabric controller decides to kind of put a service backup grade on that box, you're dead. So essentially, it will decide to shut down the box, and it doesn't really care about what your application is running. So what Windows Azure, as a practice, suggests that you need to purchase a minimum of 2 web roles to support 24/7 operations. So, and obviously it's load balance, so you kind of you get the benefit of moving multiple users across the board using the load balancer, and it's all of the web role is accessible through HTTP, HTTPS, and HTTP, and the communication between the web role and the worker role, probably it's more of an application architecting part of it. So I'm going to take that separately. Now let's come down to the VM role instance. So VM role is something what Microsoft brought out with the intent that when you guys develop your application on premise, you're bound to use something different from the base Windows 2008 Server OS. You're going to have .NET Framework 4.0 or 4.5, which is recently out, and you would obviously use third-party components. But apparently, sadly speaking, the third-party components will not get installed on your web role or your worker role because you do not have access to that. So what does Microsoft give you? It gives you a VM role where you actually have access into the independent VM, and you can go install whatever you want on top of it, and you can go about running that thing. But hold your thought there. There's a difference, and the difference is that this virtual machine role which you pick up and you go ahead and install your application, it doesn't, I mean, once it's done and over with the work, and assuming you restart it, you've lost your state. So by state I mean whatever installations that you've done, it's gone back to the original image, to what it was. So it's really not persistent in nature. So Microsoft would be coming out with persistent VM in maybe it's expected in July 2012. So that's one thing which the whole community's been crying about, is we need persistent VMs. So there's a different debate on persistent VMs being similar to what infrastructure as a service is, but we get down to that later. So from a Azure compute standpoint of view, you have role classification, very similar to what you see on-premise from a layered architecture standpoint of view. You have presentation, you have business, you got, and the DB obviously is going to be SQL Azure, or you're going to end up using tables. Fine, that kind of closes the story on the compute part. Moving on to the next slide. There's one thing, however, I want to kind of make a point out here. Azure does not support auto scaling. We have load balancing. Auto scaling is different from load balancing. Auto scaling is, let's say you have a website of online ticketing and suddenly you get a surge of users coming in. Apparently on Windows Azure you've gone ahead and asked for 4 web roles, but however when the application sees a spike and it kind of needs more web roles to be running to support that kind of capacity, Azure does not automatically add more web roles to it if you have not purchased it. So there's a difference. However, Amazon gives you the feature of auto scaling, and I'm sorry, Windows Azure does give you an API to achieve the same functionality, and that's it. Moving on to the Windows Azure storage. Now from a storage standpoint of view, we have blobs, canonical in nature. They are binary large objects used to store audio, video, whatsoever you want to go ahead and put it. So they are blobs. Okay, as we get into the dev story, we see how blobs are kind of structured, but largely, you know, how they're stored and at the hardware, at the VM level. That's something which you get to that. I'm sorry. Next, we're coming down to tables. So these tables in Windows Azure is not as the same as the relation in tables. These are different. I mean, they just have a name value pair and a primary key, and that's it. So there's nothing more to the tables part of it. And you have the queues. Now these queues is it's a standard functionality to go ahead and store, but they're different from what you expect the IBM MQ or the MSMQ on the Windows Server 8 2008, because the MSMQ or MQ is going to support a lot more features in terms of you know, first in, first out, delivery node. I mean, plenty of features which is there, but that's not really there. So one would argue, hey, why are you giving me queues? I mean, it's kind of useless. But since it's there, I mean, it's probably got some use to the entire gamut of things. Moving on to the Windows Azure Fabric Controller. Now we get into the meat of the matter. So we got a Fabric Controller. Fabric Controller is actually running off a separate box. It manages a set of 4 to 8 servers, and what it does, each of the server actually has a Fabric agent installed in it, and each server physical box may end up running multiple VM instances. So the Fabric controller understands why the communication to the Fabric agent installed on the box. Just give me a minute, please.